Okay, here we go, day 2, separation of variables. The equations just get a little more difficult. On this one, you have to divide by 1 minus y dy equals x dx. Then you're going to integrate. You have to do a u sub here. Let u equal 1 minus y. So du equals negative 1 dy. That's important because most people leave out that negative. So now you have negative integration of 1 over u du equals the integration of x dx. This is negative natural log of u equals x squared over 2 plus c. I'm going to multiply by my negative so I get my natural log of u by itself. This is negative x squared over 2 plus c. You do not need to multiply the c by a negative. When you have an initial case, it will take care of itself. Now, to solve this, you have e raised to that power, e raised to that power. You end up with just u, which was 1 minus y. Here you get e to the negative x squared over 2 times e to the c. Because remember, if you have this common base, you add your exponents, which is what we have here. Now, e to the c is a number that comes out of your calculator, so it's a constant, and we just wrap it to the front. You get c e to the negative x squared over 2, 1 minus y. Then you're going to subtract your 1 and multiply by a negative, and you end up with y equals 1 minus c e to the negative x squared over 2. Okay, that was really quick. Let's do it again. On this one, I want to add that 2xy to the other side of my equation. And I'm going to rewrite y prime as dy dx times 1 plus x squared equals 2xy. Now you divide by y, you get 1 over y, dy equals 2x over 1 plus x squared dx. And you integrate. This time you get ln of y on this side. Here you need a u sub. U is equal to 1 plus x squared. So du is equal to 2x dx. You make your substitution and you're now integrating 1 over u du. And you get ln of y equals ln of u plus c. Plug your values back in, and you have ln of 1 plus, ln of y, that's fine, equals ln of 1 plus x squared plus c, e to the power. This side you get y, this side you get c, e to the 1 plus x squared. All right, those two worked basically the same way. When you start working on number 3 here, be careful, because you end up with 1 over y squared dy equals x dx, and you integrate. You want to make that the natural log of y squared, and it is not. Be careful. This is really the integration of y to the negative 2 dy, integration of x dx. This becomes y to the negative 1 over negative 1, x squared over 2 plus c, or this is negative 1 over y equals x squared over 2 plus c. You can take the reciprocal. First multiply by your negative 1, get 1 over y equals negative x squared over 2 plus c. Again, you do not need to multiply the c by negative, because when you have an initial condition, you'll calculate that c value. Now you can reciprocate both of them, and you have y equals negative 2 over x squared plus c, and that's your answer. Okay, you can do this one on your own. The answer should be y equals c e to the x cubed over 3 minus 1. All right, next page. This one has an initial condition. They told me when x is 0, y is 1. Find the particular solution. Be careful also, this has got a minus sign in it. So I'm going to subtract that over to the other side. So I have e to the negative x squared times y squared minus 1 dy equals xy dx. I got to get my y's this way, my x's that way. So I have y squared minus 1 over y dy equals x divided by e to the negative x squared dx. Let's clean them up before we integrate. This becomes y minus 1 over y. This is x e to the x squared dx. Integrate. This just becomes y squared over 2 minus the natural log of y. This you need a u sub. du equals 2x dx. So du is over 2x equals dx. I end up with a 1/2 out in front, and I integrate e to the u du. Y squared over 2 minus ln of y equals 1/2 e to the u, which is x squared, plus c. Okay, at this point, you want to solve and find your value of c. Why do I have a negative in there? I missed a negative somewhere. Oh, I subtracted this. This should be negative, sorry. There we go, that looks better. Now, plug in your value 0 for y, so you get, you put 1 in for y, so you get 1/2 minus the natural log of 1 equals negative 1/2 e to the 0 plus c. So c is equal to 1/2. Oh, how could that be? Nope, c is equal to 1. Watch my algebra today. All right, because this is 1, you got a negative 1/2. I'm going to add that to that because this is 0. All right, back to where we were. Come back to this equation. You get y squared over 2 minus ln of y equals negative 1/2 e to the x squared plus 1. And you can stop here because it's not easy to solve for y. This one's going to be very similar. You can work it. Your answer should be y equals 8e to the x squared. This one is y equals 3e to the 1 minus 1 over x. Work those, see if you can get those answers. Got it on your video? There you go. All right, next, an application problem. Okay, at the beginning of 2010, a landfill contained 1,400 tons of solid waste. An increasing function W models the total amount of solid waste in the landfill. Planners estimate that W will satisfy the differential equation dW dt equals 1 over 25 W minus 300 for the next 20 years. Find the particular solution with the initial condition of W of 0 equals 1,400. Be careful on this. A lot of times you're tempted to, first thing to do is this, and get W over 25 minus 12, and then just move the 12, or move the whole thing. You don't want to do that. Okay, you get the wrong answer that way. Because when you add the 12, you get dW dt plus 12 equals W to 25, and no. So you're going to do what you did. You get 1 over W minus 300 dW equals 1 over 25 dt, and then integrate. If U equals W minus 300, du equals dW, so you get the natural log of W minus 300 equals 1 over 25 T plus C. Now you plug in your initial conditions. So this is ln of 1,400 minus 300 equals C. So that equals ln of 1,100. So plug that into your equation. 1 over 25t plus ln of 1100 e to the power, this becomes w minus 300. This becomes e to the 1 over 25t times e to the ln of 1100. Remember, when you add up here, the bases are the same, so you add your exponents. This is 1100, so now my equation is this, 1100 e to the 1 over 25t, and you can add the 300 and you'll have your equation solved. Done. The last page deals with a slope field. You need to plot the lines at the top. It asks you to write the equation of the tangent line of the graph at x equals -1. Well, they told us when x is -1, y is 2. If I plug those values into dy dx, you get -1 times 2 squared over 2, which I believe is 2. So now you have y minus 2 equals 2 times x minus a -1. Now you plug in 1.2. 2 times 1.2 plus 1, 2 times 2.2. So y equals 4.4 plus 2, which equals 6.4. And you're done. To find the solution of the given differential equation, when I separate my variables, I do 1 over y squared dy equals -x over 2 dx. You don't have to. You could move that 2 to the other side. You can move the negative to the other side, but I always try and keep that y pretty separate. Integrate. Remember that this is not the natural log, so you end up with -1 over y equals -1/4 x plus c. Plug in your initial conditions. -1/2 equals c. So -1 over y equals -1/4 x minus a half, multiply by a negative, and then you can flip it over and you get y equals 4 over x plus 2. Done. Bye.